Faint young sun paradox. In the Archean eon, about 2.5 billion to 4 billion years ago, before the first advanced life appeared on the planet, the sun was only about 70% as bright as it is today. The amount of heat felt on Earth was much less, and Earth's surface should have been frozen. However, ancient rocks at Isua, near the southwest coast of Greenland, indicate liquid water and that life was even present on Earth about 3.8 billion years ago, which suggests that Earth's climate had to be somewhere between the freezing point and the boiling point of water, and probably pretty close to the temperature we have today. This contradiction between the cold Earth that apparently should have existed and the temperate Earth that apparently did exist is known as the faint young sun paradox. Until now, many experimental simulations have been carried out in an attempt to explain this enigma, yet no certain result has been reached yet. The most popular explanation was that there was a higher concentration of greenhouse gases, such as carbon dioxide, in the atmosphere back then, when compared to today. This explanation assumes that, just like the average temperature of Earth is getting higher today because there are more greenhouse gases than there were before the Industrial Revolution, the presence of high concentrations of greenhouse gases like carbon dioxide should have kept the early Earth warm. Yet, for greenhouse gases to explain the faint young sun paradox, their concentrations would need to have been extremely high, hundreds to thousands of times as much as today's. While scientists analyze relatively pristine 3.8 billion year old rocks from Isua find no evidence that greenhouse gas levels were high enough to explain the faint young sun paradox, further deepening the mystery. Another explanation is proposed by Eric Wolf from the University of Colorado, Boulder, and his team. After a lot of lab simulations, they conclude that a thick organic haze made up primarily of methane and nitrogen chemical byproducts created by reactions with light may have enshrouded early Earth several billion years ago, protecting emerging life on the planet from the damaging effects of ultraviolet radiation while warming the planet as well. The arrival of the Cassini spacecraft at Saturn in 2004 has allowed scientists to study Titan, the only moon in the solar system with both a dense atmosphere and liquid on its surface. The Earth haze, Wolf believes, may have been similar to the haze that covers Titan. This new study will likely reignite interest in a controversial experiment by scientists Stanley Miller and Harold Urey in the 1950s, in which methane, ammonia, nitrogen, and water were combined in a test tube. After Miller and Urey ran an electrical current through the mixture to stimulate the effects of lightning on powerful UV radiation, the result was the creation of a small pool of amino acids, the building blocks of life. Recently, the impressions of raindrops, which fell from the heavens some 2.7 billion years ago and were preserved in ancient volcanic ash that later fossilized, were discovered in ancient rock in South Africa, shedding new light on the paradox. Until now, former explanations are mainly based on the posit that early Earth's atmosphere was filled with much greater amounts of greenhouse gases such as carbon dioxide and methane that kept the Earth warm. Since pressure rises in direct proportion to the amount of gas in the atmosphere, researchers can test the amounts of gases by calculating the pressure in the early atmosphere. To do this, Sanjoy Som, an astrobiologist at NASA Ames Research Center in California, and his colleague dropped water droplets from a 7-story height and measured the size of the imprints they made in a pan of volcanic ash from an Icelandic volcano. They concluded that the ancient atmospheric pressure was no more than twice what it is today, which suggests that the ancient Earth couldn't have had anywhere near the level of greenhouse gases as other researchers had suggested. Given that, we still don't have a solid explanation as to how the planet stayed warm.